Adams-Bashforth and Adams-Moulton formula. Okay, today we discuss about Adams-Bashforth and Adams-Moulton formula. We know that Newton's backward difference interpolation formula can be written as f of xy equals yn plus p nabla yn plus p into p plus 1 divided by 2 factorial nabla square yn plus p into p plus 1 p plus 2 divided by 3 factorial nabla cubed yn plus p into p plus 1 p plus 2 p plus 3 divided by 4 factorial nabla power 4 yn, where p equals x minus xn divided by s. Here xn is the reference point. Okay, for Adams-Moulton and Adams-Bashforth formula, we take this reference at x equals x0. Okay, our reference point is at x0, so we can take a Newton's backward difference formula in that manner. F of xy is equal to f0 p nabla f0 plus p into p plus 1 divided by 2 factorial nabla square f0 and that. Okay, here 3 factorial equals 6 and here 4 factorial equals 24. So our p equals x minus x0 upon h. Note, our reference point x equals x0 and f0 equals what? F of x0 comma y0. Okay, now we know that y1, what is y1? y1 equals y0 plus x0 to x1. x1 equals x0 plus s. S is step size f of xy dx. This is equation A. Okay, now we substitute this in that and we get y1 equals y0 plus this term, that is f0 plus p nabla f0 plus here p into p plus 1 bhag 2 factorial is nothing but p square plus p divided by 2. Here we write it. Okay, p square by 2 plus p bhag 2 nabla square f0. Okay, and as it is, that is here p into p plus 1 into p plus 2, that can be written as, okay, p cube plus 3p square plus 2p nabla cubed f0, and the another term is 1 upon 24, this term p into p plus 1 p plus 2 p plus 3 divided by 24 is nothing but p to the power 4 6p cubed 11p square plus 6p nabla power 4 f0 plus dot dot dx. Okay, here x equals x0 plus ph. Here we know that x equals ph plus x0. Okay, differentiate with respect to p, we can get dx equals h dp, and if we put x equals x0 in it, we get p equals 0, because here 0x minus x0, that is 0, ps equals 0, that is p equals 0. Okay, and now when x is equal to x0 plus h, we get x0 plus h in x0 plus h is equal to x0 plus ph. Okay, x0 get cancelled, p equals h get cancelled, p equals 1. Okay, ph equals h, that is p equals 1. Okay, here it is. Okay, now in the second phase, y1 equals here y0 plus h, p equals 0 to 1. Okay, when x equals x0, we get p equals 0. Okay, and when x equals x1 equals x0 plus h, we get p equals 1. So integration limit p equals 0 to 1. Okay, and f0 and that terms remains same, and here dx can be written as hdp. Here a is, and this is, here a is, and this is dp. Okay, now integrate this. Okay, if we integrate this, here a is, and f0 dp, that is f0 dp. Deep integration of dp is nothing but p, and we put that 1 p 1 0, that is nothing but 1, and the second term p nabla f0. Nabla f0 is constant, and if we integrate this p dp, we get p square upon 2 1 to 0, that we can get 1 upon 2 nabla f0. And if we integrate this with respect to dp, we get p cubed upon 3 into 2, that is nothing but 6, and we put that integral, that is 1 to 0, and we get 1 upon 6. Okay, and here p square divided by 2 into 2, that is nothing but 4, that is, and we put that 1, that is 1 upon 4 nabla square f0. And similarly 1 upon 6 p to the power 3 dp integrate korle amra pai, okay, 1 upon 4, that is p to the power 4 divided by 4, and we put p equals 1, and here 3 p square dp is nothing but p cube divided by 3, and we put p equals 1, plus 2p dp 2 into p square भाग 2 and p equals 1. Okay, nabla cubed f0, and same 1 upon 24 p to the power 4 is nothing but p to the power 4 dp is nothing but p to the power 5 divided by 5, and we put that p value is 1. Okay, 1 upon 5, so 1 upon 5, 6 as it is, and p to the power 3 dp is nothing but p to the power 4 divided by 4, so we get 6 into 1 by 4, here 11 into 1 upon 3, okay, and here 6 into 1 upon 2 nabla power 4 f0 plus dot dot. Okay, now we can write y1 equals y0 plus a is, we take common as f0, and we get 1 plus half nabla plus 5, 1 upon 6 plus 1 upon 4 is nothing but 5 upon 12. Okay, here 1 upon 6 plus 1 upon 4 is nothing but 5 upon 12, and here 1 upon 4 plus 1 is nothing but 5 upon 12, and here 3 upon 8 nabla cubed, here 3 upon 8 nabla cubed, here 5 upon 12 nabla square, and here 25 1 upon 72 nabla power 4 plus dot dot f0 as it is. This is y1. Okay, here we see that here y1 and y0 at the right side, and nabla f0 is nothing but we know that nabla f0 is nothing but f0 minus f of f sub minus 1, and nabla squared f0 is nothing but nabla f0 minus nabla of f sub minus 1. Okay, that is nothing but f0 minus f minus 1 minus f sub minus 1 minus f sub minus 2. This is nothing but f sub 0 minus 2f sub minus 1 plus f sub minus 2. So we can see that above relation depends on y0, y sub minus 1, y sub minus 2, y sub minus 3, y sub minus 4 as it is, all of which are known. Hence this formula can be used to compute y1. We can therefore write it as, so y1 p, this is the predictor, this p denotes as the predictor formula. Okay, y0 plus h into that is 251 upon 720 nabla power 4 f0. Okay, this is called Adams-Bashforth predictor formula. Okay, now this predictor formula can be written as this. Okay, y1p, y0, we neglect that fourth and the higher order term, and we get y0 plus h f0 plus half nabla f0 plus that is. Okay, we know that nabla f0 is equal to, nabla f0 is nothing but f0 minus f sub minus 1. Okay, we put that. Half nabla f0 is nothing but half f0 minus half f sub minus 1. Okay, now 5 upon 12 nabla square f0 is nothing but, we see that nabla square f0 is nothing but f0 minus 2 f1 plus of minus f2. Okay, and we can write 5 upon 12 f0, 5 upon 12 f0, 5 upon 12 f0, 2 into 5 upon 12 f sub minus 1. Okay, and then 5 upon 12 f sub minus 2. Okay, this. Now 3 upon 8 nabla cubed f0, that is for nabla cubed f0, we see that nabla cubed f0 is equal to nabla of nabla squared f0. We see that nabla cubed f0 is nothing but, nabla square f0 is nothing but f0 minus 2f sub minus 1 plus f of f sub minus 2. Okay, then we can calculate nabla sub f0 is equal to f0 minus f sub minus 1. Okay, for that term we can get 2 into nabla sub f1 means f sub minus 1 plus minus plus 2 into f sub minus 2, and nabla sub f nabla f minus 2 is nothing but f minus 2 minus f sub minus 3. Okay, then we get nabla cubed f0 is nothing but f0 minus 3f1, 3 f sub minus 1, 3 f sub minus 2 minus f sub minus 3. Okay, then we put that in this term, and we get 3 by 8. Okay, 3 by 8 f0 minus 3 by 8 into 3 f sub minus 1. Okay, that. Okay, 3 by 8 f sub 0, 3 by 8 into 3 f sub minus 1, 3 by 8 into 3 f sub minus 2 minus 3 by 8 f sub minus 3, and if we calculate this we can get this term. Okay, y0 plus h, okay, into here for tick mark f0, this tick mark for f0, and if we calculate this, we get 55 by 24 f0, and if we calculate for dot, we can get minus 59 by 24 f sub minus 1, and if we calculate for a star mark, we get f sub minus 2 37 upon 24, and here only f sub minus 3 by 8, and we can write it as 3 into 3 upon 24, that is 3 by 8, that is 3 by 8. We can write this, and this formula can be written this fashion, that is y1p is equal to y0 is upon 24, 21 upon 24 get common. Okay, 55 f0 minus 59 f sub minus 1 plus 37 f sub minus 2 minus 9 f sub minus 3. This is called predictor formula. Now we talk about corrector formula. Okay, a corrector formula can be derived. A corrector formula can be derived in a similar manner by using Newton's backward difference formula at f1. Okay, for f1 we can write Newton's backward difference formula at x instead of xn equals x1. Okay, our reference point at x1. Now we can write this f of x y is equal to that f1 plus p nabla f1, where p equals x minus x1 upon h. x1 is the reference point. Now substituting equation 2 in a, our equation number a is in this page. Okay, it is in this page. Now we get y1 y0 plus x0 to x1, and that p square भाग 2 plus p भाग 2 nabla square f1, and that is dx. Here x equals x1 plus ph. Now dx is equal to koto? Dx equals h dp. Okay, now when x equals x0, we get p equals minus 1. Why? Because x0 minus x1 equals ph, that is nothing but minus h is equal to ph, that is p equals minus 1. Okay, now when x equals x1, that is p equals 0. Now we solve that. y1 equals y0 plus h minus 1 to 0 plus f1. This we can write this. Okay, and h dp for dx h dp. Okay, now y1 equals y0 plus h. Okay, here we try to integrate this. Okay, y1 y0 plus h minus 1 to 0 f1 with respect to dp. f1 is constant. Okay, integration of constant is nothing but this constant is outside. Okay, and dp, integration of dp is nothing but p minus 1 to 0, and the second term p nabla f1 is the outside of the integration. p square भाग 2 p dp is nothing but p square भाग upon 2 minus 1 to 0. Okay, and p square dp is nothing but p cubed upon 3, p cube upon 3, and 1 upon 2 is also, and p dp is nothing but p square upon 2 and 1 upon 2 also. Okay, and the third one is in this manner. Okay, then Then y0 plus a is f1, because if we put 0, that is 0, and minus 1, that is 1, f1 into 1, that is f1. And this, if we put the upper limit, that is we get 0, and minus 1 squared, that is 1, divided by 2, that is half, minus half nabla f1. Okay, and the third term, that is 0 and 0, and if we put minus 1, okay, we get plus 1 upon 6, and here minus 1 upon 4. Okay, and that. Okay, now y0 plus a is f1 minus half nabla f1 minus 1 upon 6, that is 1 upon 6 minus 1 upon 4 is nothing but 1 upon 12, and here minus 1 upon 24. Okay, nabla cubed f1, and similarly. Okay, the right side of this equation 3 depends on y1, here y1, here y0, and the second is nabla f1 is nothing but we know that nabla f1 is nothing but f1 minus f0, her f1 is nothing but y1 minus y0. Or this means right side of equation 3 depends on y1, y0, y sub minus 1, y sub minus 2, and dot dot dot, where we use y1 of p instead of y1. Okay, this is the predictor formula. The predicted formula is obtained from equation b. Okay, now this is called corrector formula. y1 of c, y0 plus 1 minus half nabla minus 1 upon 12 nabla square, f1 p get common. Okay, here, that we write here. Okay, this is called Adams-Moulton's corrector formula. We can write this in that fashion, with neglecting the nabla power 4 term and the higher order term. Okay, y1 of c is equal to y0 plus a is, here a is, okay, f1p, okay, minus half nabla f1, we already discussed about this, that is 1 upon 2, nabla f1 is nothing but f1 minus f0, and nabla square f1p is nothing but nabla square f1 is nothing but that f1p minus 2 f0 plus f sub minus 1. Okay, and then nabla cube, that is here. We previously see that here nabla cubed f0 is nothing but f0 minus 3 f sub minus 1 plus 3 f sub minus 2 minus f sub minus 3. For f sub 1 minus 0 here, minus 1 here, minus 2 here. Okay, and here y0 plus a is, here LCM of that is nothing but 24. For f1, that is 24 f1p, we mark this as star mark. Okay, minus 12 f1p. For f0 we mark it as dot, and here. Okay, then we calculate that, then we get 9 f1p plus 19 f0 minus 5 f sub minus 1 plus f sub minus 2. Here 24 minus 12, there is nothing but 12 minus, this is nothing but 12, and this minus, that is 10. here also minus f1p, that is nothing but 9, and here 12 plus 12, here 4, that is 16, 16 plus 3, that is nothing but 19, and here for tick mark, that is minus 2 minus 3, that is nothing but minus 5, and my f of minus 2, that is called Adams-Moulton corrector formula. That's it.